In today's video, we are going to talk about multiplication of complex numbers. In multiplication of complex numbers, the very key note that you should know here is that anytime you multiply an I with an I, you get an I squared, which is -1. So with this in mind, let's continue with our multiplication. Let's say we have a first function z1 to be equal to x prime plus y prime I. We have z2 to be equal to x prime prime plus y prime prime I. So the product of z1 and z2 becomes, we multiply the two functions, so it becomes x1 plus y1 I multiplying x prime prime plus y prime prime I. So in doing so, you have this to multiply, and that gives us x prime. So the x prime is multiplying everything here, okay? So that gives us x prime times x prime prime gives us x prime prime plus x prime y prime prime I. Okay, so that's for the first part. So the other part also gives us, so now the y prime I is also going to multiply everything here. Okay, that also gives us y prime I times x prime prime. So y prime I times this gives us x prime prime, so plus y prime prime I squared. This is I squared because the y prime here is I and the y prime prime here is I. Okay, so the I times I gives us I squared. Let's take a practical example to explain further. Okay, so let's take an example. So let's say we have z1. We have z1 to be equal to 3 plus 2i, and we have our z2 to be equal to -1 minus 4i. So the product of z1 and z2 becomes 3 plus 2i multiplying -1 minus 4i. So let's expand. In expanding, we take 3 and then we multiply through with this, so that gives us -3 minus 12i, and then we take the 2i and multiply with this. Okay, that also gives us minus 2i minus 4 times 2 gives us 8 into bracket I times I gives us I squared. So I squared, which is -1. So we already know that I squared is -1. So this gives us -3 minus 14i minus 8 into bracket negative 1. So negative 8 times negative 1 gives us positive 8. So positive 8 plus negative 3 gives us 5 minus 14i as our final answer. So comparing this to the standard form of a complex number, which is a plus bi, our real part is 5 and our imaginary part is negative 14. Let's take another example. 6 plus 5i multiplying 6 minus 5i. Okay, for the sake that some students wouldn't need the whole solution but they need a final answer, I'll be giving you a shortcut as well. So when I look at this, I can simply say that the answer is 61. I can simply say that the answer is 61, and I'm going to tell you why. Anytime you multiply a complex number by its conjugate, you get a real number. What do I mean by a conjugate? What I mean by a conjugate is that if you're being asked to find a conjugate of a complex number, you simply change the sign. Let's say we have a plus bi. The conjugate of this becomes a minus bi. So the conjugate of a complex number, we simply change the sign between the real number, the real parts, and the imaginary parts. Okay, so if it is plus, it becomes negative. Okay, so anytime you multiply a complex number by its conjugate, you get a real number. And the fastest way I had my 61 is that anytime you multiply a complex number by its conjugate, is just the sum of the squares of the numbers involved. Okay, so 6 squared plus 5 squared, which is 36 plus 25. Let's continue. We are going to expand, and after expanding and simplifying, we are still going to get back our 61. Let's expand and see what we get. So we take the 6, we multiply through. That gives us 6 times 6 is 36 minus 65 is 30i plus, we now take the 5i and multiply through. That one also gives us 5. So 5i times 6 gives us 30i minus 25 times negative 1. Negative 1 because our I times I gives us I squared, which is negative 1. So we now see that this one cancels this. Okay, so we are now left with 36, and negative 25 times negative 1 gives us 25. So plus 25, that gives us an answer of 61. Okay, so the shortcut here is that anytime you are multiplying a complex number by its conjugate, is just the square of this plus the square of that. Okay, let's take another example. So the another example we have here is 2 plus 3i all squared. Okay, so this time around it's not multiplying its conjugate, but it's a complex number multiplying itself. Okay, so this is the same as 2 plus 3i times 2 plus 3i. Okay, so this time around it is not multiplying its conjugate, okay, but it is squared. So how do we find the square of that? So another thing we should know here is that anytime we have a plus b all squared, the simplest way to find this is a squared. A squared, you square the first one plus multiply the first one with the second one and then by 2. Okay, so 2ab plus square of the second one plus b squared. So put this in mind. Anytime you have something of this form, this is how you expand it. Okay, so let's take our number. Let's take our complex number. So by doing so, we will get 4 plus 2 times 3 is 6. 6 times 2 is 12. 12i, and then plus this one squared gives us 9 into bracket negative 1. This also gives us a value of, so negative 9 plus 4 gives us negative 5 plus 12i. So that is that for this also. Let's take more example. 7i times 8i. So we can see that 7i times 8i gives us 56, and then I squared is negative 1, so negative 56. Let's take another example. Negative 4i times negative 3i. You can go on and find the answer. So negative 4i times negative 3i also gives us negative 4 times negative 3 gives us positive 12 into bracket negative 1. Okay, that also gives us negative 12. Let's take another example. We have 5i into bracket 3 plus 4i. So we just expand and that gives us 15i plus 20 into bracket negative 1. So which is negative 20 plus 15i. Okay, so every time you have to express it in the standard form, which is a plus bi. Okay, so the real part comes first and then the imaginary part. Let's take another example. Root of negative 6 times root of negative 30. So this could be expressed as root of 6 times root of negative 1 times root of 6 times root of 5 times root of negative 1. So the root of negative 30 has been expanded to this one. Okay, so 6, 5 is 30, then times -1 gives us the -30. So this becomes root of 6 times root of 6. Root of 6 times root of 6 gives us root of 6 squared, which is the same as 6, right? Times this with 5, and then root of -1 times root of -1 gives us root of -1 all squared. So this square cancels the root sign, giving us 6 root of 5 into bracket -1, right? That gives us -6 root of 5 as the answer. Let's take our last example. So the last example we have here is root of -25 multiplying root of -9. So this is the same as root of 25 times root of -1 multiplying root of 9 times root of -1. So when we expand this, root of 25 gives us 5, root of 9 gives us 3, and then this one times this one gives us -1. So the final answer here becomes -15. But in the next video, we're going to talk about rationalization or division of complex numbers. Stay tuned.